Now I am taking some more problems based on inverse trigonometric function. These problems are from your NCERT book. Okay. So we start with the left hand side. Cot inverse under root 1 plus sin x plus under root of 1 minus sin x upon under root of 1 plus sin x minus under root of 1 minus sin x. Since under root 1 plus sin x can be expanded square root of cos square xy2 plus sin square xy2 plus 2 sin xy2 cos xy2. This can be written as square root of cos xy2 plus sin xy2 whole square, that means cos xy2 plus sin xy2. So under root 1 plus sin x can be expanded. 1 can be written as cos square xy2 plus sin square xy2 plus 2 sin xy2 cos xy2. This is the whole square of cos xy2 plus sin xy2. Now square remove with square root. So we have only cos xy2 plus sin xy2. The reason only is that we want to remove the square root from 1 plus sin x. So now we use this option there. So this becomes cos xy2 plus sin xy2. This becomes cos xy2 minus sin xy2. Similarly, cos xy2 plus sin xy2 and there minus cos xy2 minus sin xy2. Now in next step, this can be written as cot inverse cos xy2 plus sin xy2 plus cos xy2 open the brackets minus sin xy2 upon cos xy2 plus sin xy2 minus cos xy2 plus sin xy2. So sin xy2 cancel out, cos xy2 cancel out. Now we have only cot inverse 2 cos xy2 upon 2 sin xy2, cos and cos, 2 cos, sin and sin, 2 sin. 2 and 2 cancel out. So we have only cot inverse cot xy2. This implies that xy2, because xy2 belongs to 0 to pi by 8 belongs to 0 to pi. So xy2 is coming inside the principal value branch of cot inverse. So this cot inverse adjust with cot, we have only xy2. And here, why we make the whole square of cos xy2 minus sin xy2 here? Because x belongs to 0 to pi by 4. So cos x, xy2 belongs to 0 to pi by 8. This implies that cos xy2 greater than to sin xy2. So we make the whole square of cos xy2 minus sin xy2 at the place of sin xy2 minus cos xy2. Now I am taking one more problem. The question is that prove that tan inverse under root 1 plus x minus under root 1 minus x upon under root 1 plus x plus under root 1 minus x equal to pi upon 4 minus 1 upon 2 cos inverse x. The restriction is that minus 1 upon under root 2 less than equal to x less than equal to 1. In my previous video, important substitution is given by me. If in the question under root 1 plus x and under root 1 minus x are coming together, then the suitable substitution is x equal to cos theta or cos 2 theta. So you may be go through cos theta or cos theta, you have a choice. So now we start with left hand side here. Tan inverse under root 1 plus x minus under root 1 minus x upon under root 1 plus x plus under root 1 minus x. Put x equal to cos 2 theta. So now next step, tan inverse under root 1 plus cos 2 theta minus under root 1 minus cos 2 theta upon under root of 1 plus cos 2 theta plus under root of 1 minus cos 2 theta. Says cos 2a equal to 1 minus 2 sin square a equal to 2 cos square a minus 1. So now we use this identity. So we have tan inverse under root 2 cos square theta minus under root 2 sin square theta upon square root of 2 cos square theta square root of 2 sin square theta. This can be reduced now. Under root 2 cos theta under root 2 sin theta upon under root 2 cos theta plus under root 2 sin theta. Tan inverse root 2 are common and cancel out with denominator. So we have only cos theta minus sin theta upon cos theta plus sin theta. Now divide numerator and denominator by cos theta. So we have now tan inverse 1 minus tan theta upon 1 plus tan theta. If cos theta divided by cos theta, we have 1 sin theta upon cos theta. Now you can fill in as also tan inverse cos theta upon cos theta minus sin theta upon cos theta upon cos theta plus sin theta upon cos theta. So now this step can be expressed now tan inverse 1 minus tan theta upon 1 plus tan theta. In next step, this become tan inverse tan of angle pi by 4. 1 is replaced by tan pi by 4 minus tan theta upon 1 plus tan pi by 4 tan theta. This expression is converted in the formula of tan A minus B. So now tan A minus tan B upon 1 plus tan A tan B can be written as tan A minus B. So this step become now tan inverse tan pi by 4 minus theta. Next step become pi by 4 minus theta. Here x equal to cos 2 theta. 2 theta equal to cos inverse x. So theta equal to 1 upon 2 cos inverse x. So pi upon 4 minus 1 upon 2 cos inverse x. So this is the right hand side of your question. Now I am taking one more problem on the example of NCERT book. Prove that sin inverse 12 upon 13 plus cos inverse 4 upon 5 plus tan inverse 63 upon 16 equal to 5. हम इस क्वेश्चन को दो तरह से सॉल्व करने की कोशिश करते हैं. आपको फिर जो ठीक लगता है आप उससे उसको प्रैक्टिस करिएगा. ओके, सो वी स्टार्ट विथ लेफ्ट हैंड साइड. Sin inverse 12 upon 13 plus cos inverse 4 upon 5 plus tan inverse 63 upon 16. Let sin inverse 12 upon 13 equal to A, cos inverse 4 upon 5 equal to B, tan inverse 63 upon 16 equal to C. So if we use triangle process here, only for first two, this is sin inverse 12 upon 13. That means 12, 13. For second figure, this is 4 and 5. By Pythagoras, this become for the angle A, this is for the angle B. So this become 5 and this become 3. So now sin A equal to 12 upon 13, cos B equal to 4 upon 5, tan C equal to 63 upon 16. So now tan A equal to, by this figure, 12 upon 5, tan B equal to 3 upon 4, and this is the value of tan C. Now tan A plus B equal to tan A plus tan B upon 1 minus tan A tan B. So now next step become tan A plus B equal to, the value of tan A is 12 upon 5 plus tan B is 3 upon 4 upon 1 minus 12 upon 5 into 3 upon 4. This implies that 48 plus 15 upon 20 minus 36. That means 63 upon 16 minus 16. equal to minus tan c. So tan a plus b equal to tan minus c, because minus tan c can be written as tan minus c, or tan a plus b equal to tan pi minus c. So we have a plus b equal to minus c, or a plus b equal to pi minus c. A plus b equal to minus c. Here a and b both have the positive values. A and b both have the positive values. So a plus b never be negative to become to minus c. Not exist. So this implies that this value is now correct. So a plus b plus c equal to pi. A means, so sin inverse 12 upon 13 cos inverse 4 upon 5 plus tan inverse 63 upon 16 equal to. Here a and b both are positive. The sin a is positive, cos b is positive. That means the angle a and angle b both are the positive angles. Both are the angles positive. It never be equal to the negative value. So a plus b equal to pi minus c. So now we have sin inverse. Only this value is correct. A plus b equal to pi minus c. So put the value of a, b and c from there. Now we have again a plus b equal to minus c. Since a, b, c are positive, so a plus b plus c never equal to 0. That means a plus b never equal to minus c. So this condition is not correct for the question. So only we have this option, a plus b equal to pi minus c. So this is the correct option. Now I am using one more alternative method for this question. We start with left hand side is sin inverse 12 upon 13 plus cos inverse 4 upon 5 plus tan inverse 63 upon 16. So now the first term is sin inverse 12 upon 13. 12 upon 13 perpendicular upon hypotenuse to the, by using Pythagoras theorem we have the base 5. So now this convert into tan inverse. So this become tan inverse 12 upon 5 plus the second value cos inverse, which is also converted in tan inverse. So this becomes 3 upon 4 and the last value is in the form of tan. So this is not converted. Tan inverse 63 upon 16. Now apply 5 plus tan inverse 12 upon 5 plus 3 upon 4 upon 1 minus 12 upon 5 into 3 upon 4 plus tan inverse 63 upon 16. If x positive, y positive and xy greater than 1, then tan inverse x plus tan inverse y can be expressed pi plus tan inverse x plus y upon 1 minus xy. So here x is 12 upon 5, y is 3 upon 5. If they both are positive and 12 upon 5 into 3 upon 4, that is equal to 9 upon 5 greater than to 1. So we use this identity. So now again pi plus tan inverse, this is 48 plus 15 upon LCM are the same, we have 20 minus 24 plus tan inverse 63 upon 16. In next step, pi plus tan inverse, this becomes 63 upon minus 16 plus tan inverse 63 upon 16. Again tan inverse minus x equal to minus tan inverse x. So this becomes pi minus tan inverse 63 upon 16 plus tan inverse 63 upon 16. So you have only pi. Yeah, cancel out. So this is the second method of solving this type of questions.